Thanks for joining, everybody. Chris, thanks for being here with me. I'm pretty excited to do another webinar. We haven't done this in a little while. We have, yes, some people dropping in. Hero, thank you for, I was just about to ask if you can drop a comment to say where you are joining us from. It would be really cool so that we can see where everybody's coming in from, seeing who's joining us. So to introduce the both of us, I'm Max. I'm a developer advocate at Fused. I'm joining from the Netherlands in Europe. And then Chris, I'll let you introduce yourself.
Yeah, hello, I'm Christopher, originally from Denmark, but living in Japan right now. And I'm a data scientist at Pacific Spatial Solutions.
Great. So what we're going to do today is a bit of a different format than what we've had. Chris here is going to run us through some of the applications, some of the use case, the analysis he's been doing in Fused, and we're gonna just dive in. So I'm gonna bring up your screen and hand it over to you, Chris.
Sounds good. Thank you. So yeah, today there are a few use cases that I would like to discuss. And the first one here, we have this very cool looking map. So what exactly is this? So basically, the problem we're trying to solve is ocean health and trying to find some of the places where climate change is basically impacting the oceans. And then there's a very specific phenomena that we're trying to locate, and it's something called river plume. And we're working with a Japanese basically climate and remote sensing company, and they're trying to figure out where these river plumes are. So river plumes, essentially, I'm going to try to explain this as well as I can, is when you've got a river that transports sediment to the ocean. So this could be after like a mudslide or like an earthquake or heavy precipitation. Then this sediment will drown into the river, and then that will go to the ocean. So this can be both a good and a bad thing. In a good case, there's a decent and natural amount of sediment that can bring nutrients to the ocean, and it adds biodiversity, and it's overall a good thing. And you've got the bad kind, which is where there's an excessive amount of sediment, which of course, it's not good. It's going to completely smother all the plankton and ruin the natural habitat of the ocean. And apart from excess sediment, it can also bring along toxins, human-made wastewater, or agricultural fertilizer, which is going to completely increase how much plankton there is, which is not a good thing either. So this map shows chlorophyll. So chlorophyll is the green pigment found in plankton. So what we can use this map for is seeing where there is too little or too much plankton. And this could be an indicator of certain river plume. For example, if fertilizer was drowned into the ocean, well, then we would see an increased amount of chlorophyll. And if an excess amount of sediment is completely smothering the plankton, then we would see a decreased amount. So how am I getting this data? So this data is actually coming from Jaxa. So Jaxa is the Japanese aerospatial agency, similar to NASA in the US. And they have this super open and great source of data. So if you go to Jaxa Earth API, and then you go to datasets, then you can explore all these cool different datasets they have. And there's many of them. I won't go through all of them. I'll just quickly show the ones that I've prepared today. So the first one is, of course, the chlorophyll. I'm using the daytime half monthly, but there are other times as well as the sea surface temperature, also half monthly. And finally, we have the precipitation. So going back to our map, the way that it works is that Jaxa Earth API, it has a Python API attached to it as well. The data itself is in cloud-optimized GeoTIFFs in a stack catalog, which can be a little daunting. So the reason I'm using Fused is to make it easier for us to make these layers accessible to our customer. So for example, the chlorophyll layer, we have the Python API installed into Fused. And then I have a tiled UDF where for each of these boundaries, we extract the bounds of that tile. And then we send individual requests to the Jaxa Earth API to only get that tile. And this is super cool because it's basically running in parallel, and we can bring in multiple tiles at the same time, and then basically show, well, all of the world if we really wanted to. So right now, it's happening in real time. We're sending requests to the API, and it's sending back the cloud optimized GeoTIFFs. And because it's a cog, it means, or cloud optimized GeoTIFF, it means that we have different zoom levels. So we can actually pull in different granularities of the data, like more precise data. Of course, when I'm this zoomed out, I'm at zoom level 4 right now, which might be a little bit hard to see. But then we wouldn't be pulling in super high resolution data because it would blow up our browser. So what we can do is we can dynamically change how high resolution the cogs we're pulling in is. So as I zoom in, Fuse knows that I'm changing the zoom level. So then I can change my request to the API and say, hey, I actually want more high resolution data now because I'm more zoomed in. And it's a type of flexibility that you get with Fused, and it's kind of making this UDF is turning into some like a tile server that's in between, our customer visualizing the layers and the Earth API. So it's a super cool use case for Fused, I think. And I've had a blast developing this.
I send a link just there as well in the chat. We have an accompanying blog post that will have the links to some of the data that you're mentioning here, Chris, if people want to take a look at it. I wanted to ask, so here are you visualizing the data? Are you processing it? You're working with other sources of data as well?
Yeah.
What's going on there?
So this is mainly just the visualization part, or making the data available to our customer. So I'm pulling the data in, and then we're actually sending it out through XYZ tiles, which I'll show in a bit. For the other layers, I can turn that UDF off and turn this on. One thing to note as well is because these API requests, they have the query parameters for the actual specific time, I can very easily change the time of the data I'm pulling in. So that's actually something I didn't show before, but I can show it here with sea surface temperature. So instead of pulling in the first 2 weeks of August, I can just say, you know what, I want the first 2 weeks of September. And then the whole thing happens again. It's going to send in this new request with this new time frame, and it's going to pull in this data instead. Or I could also go October, for example. So what we would assume is that the sea
Can I
surface
ask you to zoom in a bit, Chris?
sorry.
I think it might
Yeah,
be a little
sure.
bit on the tab. So because you're editing some of the code, if we could just make the screen a bit bigger.
Sure. There we go.
No, so sorry. I mean the if you could make the UI a bit bigger so we can see the code that you're editing.
There we
go. Thank you.
Sorry. Yeah, so I'm hiding the code. It's not because it's secret, but there's a lot of it, so I wouldn't really completely bloat it out.
But so you're editing the code here on the left side, and as you're doing it, we're rerunning, and you're seeing the result directly in the map on the right side.
The new month and the new day is automatically dynamically being sent into the request, and the new requests are being made to the API, which then returns us these new tiles. And as we would expect, the sea surface temperature for the ocean around Japan in October, it seems a lot cooler than it would in August, which makes sense. And then for our final layer, we've got precipitation. So this isn't as high resolution. I think it's about 10 kilometers, I believe. But this is still the same thing. It's got great impact on ocean health because precipitation can bring in also toxins based on if the clouds have been formed above places with a lot of pollution. And it can also lead to mudslides, which then leads to bad river plumes and so on. So how are we actually bringing this data out, and how are we serving this to our customer? So if you go to any of these UDFs, we can take the chlorophyll one, for example, and we then go to, I believe, settings. Then here you get a link, an XYZ link to the XYZ tiles. These can then directly be sent to a different visualization app. So I have a different tool here called Felt. So this is purely a visualization tool. And Fuse can actually directly plug into Felt as well as other tools like QGIS. The way it works is that you basically just press here, and then you upload from URL, and then it'll create a new layer. So for the chlorophyll layer, we actually have the URL over here. And as the endpoint, I have chosen August, the first half month of August.
Same thing. Can I ask you to
2025.
make it just a little bit bigger
Sure.
with the UI, please?
Actually, here, if I try to do this, for some reason, it zooms the map in instead
Oh,
of my
that's fair.
actual browser. So I don't think I'm able to do it here, unfortunately. But
But so you're passing it in the query parameters of the
yes,
URL.
take
And
my
then
word for it. This is the link to.
and that's a parameter in the UDF in the code that you have that you're able to edit.
Exactly. So then, similar to Fused, this felt is actually sending tile requests to Fused, which then in turn sends tile requests to Jaxa Earth API, and then brings this data back. And due to the nature of this data being global, if let's say we wanted to focus on a different part of the world, not just Japan, well, then after waiting a few seconds, we can do that instead. Yeah. So this is kind of the use case. Of course, I can't show the actual ocean health visualization app, but I think you get the gist of it, how it works. We have Fuse
So
as a middleman, taking in the data in real time and then sending it to where it needs to go.
so to summarize here, the value you're getting is that you can edit it directly. One of the thing we didn't mention, maybe if you go back to Workbench, is this is in the browser directly. Like you didn't have to create a
No.
Python environment. We handle a lot of that on the back end. And then as soon as you change your code and you save it, you can directly deploy it. You can call it. And here you have basically multiple tile servers that you're created. You're doing that here from the Jaxa API, pulling in their data.
Yeah.
And then being able to visualize it anywhere. Here you're using Felt, but it could have been QGIS. It could have been a custom front end that you guys would
Yes,
have built.
exactly.
It just plugs in anywhere. You didn't have to. We didn't set up any infrastructure ahead of this call.
No,
This is
no.
all just directly done here.
And I think the most important part to really drill in is that our customer didn't have to actually fiddle with any of the stuff. Even I didn't really have to fiddle with the stack catalog and the cogs because the people at Jaxa Earth API were kind enough to create a Python library that can easily access this data, right? And because Fuse is in Python, I just install that library and now I can make direct calls to it. And again, our customer doesn't need to worry about any of that stuff. They just tell us which layer they want, and then I can bring it in directly through Fused.
If anybody that's in the chat, if you have any questions, feel free to put them in there as well. In the meantime, Chris, how about we move on to the next
sure.
application that you've been working on and you wanted to show?
Sounds good. So this is a little bit of a different ballpark, but I wanted to basically shine a light on this super interesting open data set that is available in Japan. So it's a very important topic. It's actually about road safety and road accidents specifically. So this is the official National Police Agency of Japan. They basically release this yearly data about accidents. It's very accurate where the locations are. It's got a bunch of information attached to it about the age of the drivers, the accident type, when it happened, down to the hour, even the weather. To some degree, all of this is of course manually written down, so take it with a grain of salt. But it's a very important data set to learn from moving forward. So I wanted to write a UDF that can take advantage of this. I don't want this data to be buried behind these links. I wanted a UDF that could directly go in and access those. So what's happening here is I have a UDF, and then I'm using a little bit of HTML wrangling to automatically bring out the CSV link depending on the year I give. So nothing too special going on, but I can basically give it any year, and then as long as there's data for that year, of course, it'll go in and pull that data instead. So zooming in, it's a lot of data. I think it's around 350,000 accidents per year, which is quite an amount, and definitely enough to do some very important analysis upon. And I think the powerful thing here is the fact that just same thing as before, one click, one edit, and now you've got a completely different set of accidents to analyze. So how do we actually build upon this? So the first thing we can do is create a tiled UDF. So that means that instead of rendering everything at once, we're rendering it in tiles. This is going to increase performance and parallelize it, as well as convert from points to hexagons. So most of you might be familiar with H3, but for those of you who aren't, it's a spatial index, which is a hexagon. It's very easy to work with because you can convert a lot of different vector data types to H3, and then all of them can basically talk easily together. There are different resolutions, and they're all identified by either a string or a number ID. So once we have our hexagons for our year of choice, right here it's 2021, we can now merge this with a type of road network data. And what road network data would be better to use than Overture? So Overture is this super cool open road network data, as well as they've got buildings and places as well, but most of the data is intersections and roads. What I then did was I turned the intersection points into H3 as well, and then I checked the surrounding hexagons of each intersection to see if there were any accidents there. I could then aggregate them, and then we get a map like this. So what's happening here is the color is based off of the number of injuries. I pulled this directly from the data. And the height of the hexagons, if I try to zoom in, the height of the hexagons is the number of accidents. So you might think correctly that those are very, very correlated, which they are. But there are certain places where even though the number of accidents are low, the number of injuries are high. Like, for example, a place like this. We've got 5 accidents, but 8 injuries. But over here, it's 5 of each. So that might tell us, like these very dark colors, like this is probably where we should focus first in trying to improve road safety, because this is actually where people are getting hurt. And again, the good thing about this, because it's tiled, is that, okay, let's say we don't really care about Tokyo. Maybe we want to look at Osaka, which is also a very, very common place in Japan where traffic accidents happen, unfortunately. And here, same thing. This road specifically, you can see, is very bad, a lot of accidents. This is for 2024. We could just change this, say, okay, actually 2023 is where I want to see the data for. And then we change that, and then, yeah, the distribution changes like that.
And this is all based on, so the data that you have is from the police data, that's a CSV. We didn't create any intermediate file here. Like, you're just building this as you go as well, seeing it.
Sure, let me go somewhere else, somewhere completely random. Let's go to northern part of Japan, Sapporo.
Do you know how big is this data set? Even the accident one, and then Overture. Overture is really big, but just at least the accident data set.
In terms of megabytes or records?
Both.
The megabytes, I'm not sure. I don't know if it actually says here. Probably not. It's around 300,000 accidents, 300,000
Okay.
points. So I would maybe, well, it's a CSV, so that would blow up the file size too. But we're probably talking like tens of megabytes, maybe even more than that. So quite a lot of data. And it's all of this is running, it's DuckDB aggregating this. So even if it was a million accidents, I don't think Fuse would even sweat. So
yeah, the reason why we're seeing it coming in different tiles here is one of the thing you've done is instead of running everything at once, we're running it as a tile server in the background as well. So
yeah,
there's the time here that shows at the very bottom of your code. We see a little, it says 1.76 seconds average. Like here, it's just a few seconds, like, because we're able to run every piece in just a tile. So you wrote this code one time, and then it just gets applied to wherever you're looking at on the map here.
And it's also due to the nature of the Overture data being as big as it is. It needs to be rendered in tiles because you can't. It's millions and millions and millions of intersections. Like every single hexagon you see here has been based off of an intersection point from Overture, and all these places where there are no accidents also have intersection points. I'm just not showing those, obviously. So to actually visualize such a huge data set, you need to do it tiled. Even though for those of you who have used Fused before, like writing a tiled UDF might be a little bit more daunting than writing a viewport one, which is just a single call. But when it comes to performance, it's unmatched. So I would definitely recommend learning about tiled UDFs if you have time.
So what's the outcome here after you've made this analysis here?
So the outcome is to share this with local governments as well as like insurance companies. They're obviously very interested in this type of data, and then we can basically help. In Japan, we call it like city building, but it's basically urban planning, creating a better community for everyone. Is like this is data that has been available for the last 4 or 5 years, but people still don't really know like how to use it or use it properly. So it's also just showing how simple and quick and easy it is to create a super important and impactful analysis. And I'm not even going that in depth, right? Like I'm only really displaying here. There's so much more information to be gained from this data set. As I mentioned, you've got something like accident type. You've also got the ages of the people involved. You could look at the distributions of where are young people getting into accidents, where are old people getting into accidents. Japan is a rapidly aging country, so that would probably be very interesting to look at. And so yeah, you could definitely make this analysis even more in depth.
And then you wanted to join that with another data set.
Yes, that's correct. So I told a little bit about a precipitation layer earlier from Jaxa, which was I think 10 kilometers in width, and as you might have guessed, that's a little bit too coarse to actually give us any benefit in an analysis like this. So there's actually a different option. So there is a file called GRIB file format, which I'm not sure people are familiar with. It's a little bit of an obscure file format, but it's very common in weather data. Make this full screen. So this file format is binary. It's highly compressed. It's around 10 megabyte for a file that when it's fully decompressed into something like a CSV, which is human readable, we're talking it blows up to over a gigabyte. So it's very compressed. And the reason it's so compressed is that everything is, as I mentioned, in binary. There's like run length encoding. There's a bunch of very hardcore stuff that is not very easy to work with. So there are actually some backends, specifically with Xarray. There's a backend called CF-GRIB, which allows you to directly read these files into Xarray. But unfortunately for me, I'm working with a Japanese version of GRIB, which means they use different standards.
Can you show a little bit what the code looks like, just to give an idea of like what you had to do to get this working?
I'm basically reading sections of the file. Like all this is like binary. I'm scaling the latitude and the longitude, and I'm constructing these grid arrays. It's not fun. If you go into, I believe it's if you just search GRIB or error codes, you'll see the list of how they're structured, and it'll be like section 0, 11th to 12th byte will have information about when, like the time of when this weather data was captured and so on. It's I don't want to get into it because we don't have time, but basically what I wanted to show is that with Fused, I was able to develop and make sure that when I was pulling out this data, that it came out correctly. So zooming in, this is what the data looks like. It's actually point data, or it's actually mesh data. So you can imagine that each of these points is just a grid cell. So the resolution above central Japan is 250 meters by 250 meters. And to make things even more complicated, as we move out to the ocean, the resolution actually changes. So it changes from 250 meters, 250 meters to 1 kilometer. And all this is something I need to keep in mind while I was pulling this data out. And just having that instant feedback when I was using Fused, trying to pull out certain parts of the byte string and making sure that that actually aligned. And in the beginning, like, this map looked completely awful. Like all the points were in the wrong order. It was everywhere. Some of the points were ending up like far outside Japan. So we can actually hexagonize this data as well, turn it into hexagons. And if you do that, it looks like this. So it might take a little while. There we go. This is 1.3 million hexagons, I believe, all over Japan. It also has the 3D distributions of the data. So here it's colored and has the height of the rain points that I showed before. And we could easily just merge this with the intersection data that I showed you before, and then have weather data on top of that. Of course, we would need to make sure that the actual time of the weather data aligns with the time of the accident.
But you have it here as parameters. Like you
yes,
have, we can
exactly here.
change if I recall correctly, these are like 5-minute interval
Yes,
data
these
sets.
are different files. So I could, in theory, go in here and say 5, and now nothing's cached. So this will be a test to see how fast this runs. Is this actually running? It couldn't find that. Maybe I will do. Oh, this is a sample. It's a different folder.
But this is how you know it's real.
Yes,
it's a real demo.
I can change the threshold. Sorry, let me change the threshold instead. I'm using a sample. That's why. So here I can change the threshold, so it's showing a different level of rain. It's not showing all of it. It's definitely not the fastest UDF, but it works, and that's the incredible part. Like running this locally was such a pain, and having it on Fuse is so much easier.
But yeah, that's the part to really hone in on. That is like you have the data here. We can see line 3, there's an S3 path. You have that data there, and we're computing all of that like on the fly. So if there's even new data that comes out, because I'm guessing I think you may have told me there was even forecast data, but even there's new data that comes out. Like you've basically just had your whole pipeline here, and we have the same thing as we had before, is that you have a URL, you've directly deployed this without having to think about it as well. Every UDF comes because it's this serverless compute, you can just directly hit it with whatever parameters that you have or want to pass.
And it's all developed in Python as well, which, well, it's what I'm familiar with. So that's why I decided to write this custom GRIB loader in Python. So
I wanted to ask you about that one. Did you do this before or after we introduced some of the AI features, and was it helpful in that or not? Because it's like a pretty specific problem you were having, where it's like the Japanese version of it, and just looking at from what you were showing in the code base, it looks like there's a lot of back and forth and error and trial in doing that.
So unfortunately for me, AI wasn't. This was maybe half a year ago, a year ago. I developed this, at least to begin with. It took me several months to get this completely ready. But unfortunately, so AI hadn't been added to Fuse back then, so I had to really kind of just do it as I went. But the problem is LLMs are only trained on actual data that's out there, right? And there's very little data out there on Japanese versions of GRIB data. So what was happening was I was asking it questions, and it would just send me down a rabbit hole. It would link me to the wrong type of GRIB, and it would say like, oh yeah, check out this template, and then I would go, and that like the template that I needed was not even the same one.
Yeah.
It was a completely different number that doesn't even exist on the official website. So I was digging through Japanese forums and Japan's version of Stack Overflow and so on, and finding like small code snippets. Like one person who found out how to decode the run length encoding, then I grabbed that. A different person who found out how to structure the code and all this stuff. So I was finding different areas where I could kind of learn from and then fill in the gaps, and then I managed to write this code.
Yeah, the reason I'm asking is here, maybe if you could pull up the runtime tab, is that we're also, so here you have the actual time that it took to run, but if you can just drag that on, we can see all the logs here of the code. If you can drag that tab, yeah, there.
Yeah.
So like every time you're returning or printing something, this shows up in the runtime. And the way that we've implemented some of the AI feature now in Fused is that we don't just write code, but we also have access to all these logs. So because we're running the code for you. It's the serverless part. The AI has this context of the data that you have, the logs, the code that you're running. So if something doesn't look right, it will see the error itself. You don't have to sort of copy paste it. That's why I was curious. It feels like it would have been an interesting use case to
It
test
would
that
have
out.
been great to have it back then. So
So you did this like
maybe
2 months too early.
yeah, kind of. Maybe I'll make some improvements to it, and then AI can help me. Maybe it's caught
Hmm.
up. Maybe it hasn't. I guess we'll see. But this is a very niche use case that I wanted to
Yeah.
share, and finding a way to make good use of this data that a lot of people aren't familiar with, um, to improve traffic safety is one of the things we're actively working on as well.
I shared in the chat earlier like one of the UDFs that you were showing. If people want to take a look at that, Chris, you shared some of the code, not all the UDFs here, but some of the ones that you were showing. So if people want to see by themselves like how uh, this code runs, they can actually run it themselves. You can just directly head over to Fused. You can click on the link here. It will take you to the catalog where the code that Chris put out is. You can make a copy of it and start playing with it if you're interested. And we'll post about it later as well. I posted in the chat a bit earlier. There's a blog post that we have that's accompanying here with some of the data sources and some of the UDFs that you have, Chris. So if anybody is in here, feel free to ask any questions to Chris about how he's doing all of this. But also, if you want to try it out for yourself, we have some of the links, and you can do this. So you don't even have to just take our word for it. You can take
Oh,
it and you can build on top of it. For all the people working, no, we don't have the GRIB one, but for all people working with the incidence data or seeing how to use Overture, I really encourage you to go have a look at that.
yeah.
Did you have anything else on this use case, or should we move on to the next one?
I think we have time to move on to the last one.
I I think this is one of my favorite ones from
Oh yeah.
what you showed.
Okay. Well, let me first again share the use case. So we're actually developing this app in-house. So for those of you who have been to Japan in the summer, you might know that it can get very, very hot and very humid. So it's becoming more and more important to show people places where they can cool off, and like nice places where if they want to go from A to B in the city, there's a route that takes you through all the sun, which obviously you don't want, or most people don't want, and that's a route that takes you to the shadow or the shade. So we're developing this app to help people basically enjoy Tokyo more. And one of the features that it has is that it's got this interactive shadow map where you can basically see how the shadows get projected off the buildings and the trees at different times of the day. And then the route here basically changes based on the shadow as it's actually calculating. It's still in development, so it's a little bit janky right now, but basically based on where the shadows lie, the route will take you to like uh, a different path through everything. And there are also points of interest that people might want to go to, as well as an underground map. So if people want to go completely underground instead, they can do that. And then let's say that you want to go in the sunny route, well, then you can choose that as an option as well. So what I've been working on is a way to improve this would be to improve the shadows. So this is a different data source that brings this shadow, and I wanted basically a more accurate way of estimating where the shadow is. So the way that I decided to do that is to go to the Tokyo Digital Twin Viewer. So this is also open for everyone to go. I think there's a link to this in the blog post coming out. But this tool basically has a lot of open 3D data for Tokyo. So if we explore the map data here and we go to point cloud, we can actually display some pretty cool point cloud data for Tokyo. So this is central Tokyo. This is around Tokyo Station. This is where a lot of the corporate offices are, and they've got all these super cool point cloud data. And this is all, again, you can go and download this if you go back in here, and then you instead go down to point cloud download. This is all in Japanese when you first come in to make sure that you translate it using some tool. pressing this tab, now you can actually access each of these tiles and then download it as a LAS file. So what I did was I decided to download all these tiles. So there's 121 of those. I then ran a batch job in Fused to convert them from point cloud to something called a DSM, a digital surface model. So following the contours of the point clouds. So if there's a building, it'll grab the points at the top. And if there's only ground, it'll grab the points at the bottom. And then once we've got this digital elevation model, you call it as well, then you can actually simulate where the sun is at different places and then calculate the shade. So for every point in the DSM, the only thing you need to figure out is, am I being blocked by a different part of the DSM while looking at the sun vector? So let's see what that looks like. So this is all stored in a Zarr file, by the way. For those of you who are familiar with Zarr, it's a multi-dimensional data format, like for storing multi-dimensional arrays. It can be chunked and it can be accessed very, very efficiently. So as with the other UDFs, this is a tiled UDF where each tile goes into that Zarr file and then only grabs a very specific part of that Zarr file. The data has been generated for a whole month. So up here, as you might be able to see, we're choosing the start time and the end time. So we're only showing 1 hour, 1 hour right now. So 12 o'clock in the afternoon on the 1st of August. So that's why the shadows are very short. We can tell that the sun is very high up in the sky. But let's say instead of just showing the shadows for 1 hour, maybe we can show it for a longer period than that. So let's say from the 1st to the 8th. So now what we're doing is we're aggregating over a whole week worth of hourly shadow data. And now you can see that the city basically comes to life. It looks a lot more realistic because instead of just showing one time step of shadows, we're showing how the shadows are being cast over, I believe this is 100 hours, something like that, right? Yeah, like 102 or so hours in 1 week worth of data.
This looks incredibly cool.
And you can make out like how there are shadows in these kind of grooves on top of the buildings. How certain, if I go to like an intersection like this, like you can see these kind of triangular patterns. So these are the angles of the corner of the building casting straight lines onto the road, or just completely dark spots in between these buildings that have been shaded in pretty much most of these hours, or even the train lines you can make out. So this is I don't think I mentioned it, but it's a 0.5 square meter resolution. That's so this will of course depend on the density of your point cloud. If you have more points, a more dense point cloud, then you've got more points to sample from, and you can make a more high resolution digital surface model. So this seems like a good balance for this point cloud data in particular. And yeah, when I first created this map, I was so surprised with how well it came out. I'm still working out the kinks, making sure like you can see the cars here. So we've got to remove those, of course. But this would be a super highly accurate data to get an estimate of how much shade certain areas get, especially because this data was gathered last year, I believe. So the trees that you see and the buildings that you see have most likely not changed that much. So this is very recent.
You mentioned batch jobs. Can you explain a little bit what those are and how it's different from other types of runs?
So right now we're running stuff in a UDF. So this is using a smaller, more like real-time instance that'll give you immediate feedback on the code you write. So for jobs where you need a larger machine, so this is, as mentioned, 121 point cloud files. If I just quickly show this here, you can see the size of the raster itself. The total size, it's 9,000 by 10,400 pixels. That's 90 million, I believe. That's a lot of data. So to process all that, we run it in a batch job. So it's a much larger machine where you give it the Python code that you want to execute, and then you press run and you get a job ID. And for this case, it took around 30, 40 minutes to run. But we're generating data, so we only need to generate it once. And once we've generated it and we've spit out this this super efficient Zarr file, well, then we can start visualizing and doing all the fun stuff. So the batch job is there to take care of the really heavy processing that a normal like user-defined function wouldn't be able to do.
I actually don't know if you know this, Chris, but now we've also introduced that in the decorator of the fuse.udf, you can pass an instance type. We probably wouldn't do it here.
No, not here, but up here you would do it,
But
right? I
up
think,
here, you can pass it. If you do that with like a hello world UDF, we can actually just show it right now. And if you were to realize like midway, hey, actually, I need something that I need this to run for 5 hours. This is a big job. Like we've added that directly in the UI now in Workbench. You can say, hey, don't run this as this like very fast, very snappy job. Run it as a dedicated batch because it's like you were saying, it's something I just needed to run one time because it's a big ingestion job, for example. Like we've added all of that directly in here. So you can do all of that from
And
Workbench.
some workflows aren't meant to be run in real time. As I mentioned, this is data processing. This is only supposed to be run once, and it's it's a lot of data. So in that case, it makes sense to use that instead of a UDF. So for future work, what I haven't done this just yet, but what I want to do is I want to link this with basically road data. So we've got this we also made this in-house, but this is a cool
I
road
haven't even
network
seen
data.
this is cool.
Road network data of central Tokyo. So we have different types of roads here. These dark orange one is like normal roads. We've got road crossings as well. So like this is intersections, as well as these yellow lines are parkways. And I believe there's like underground line strings as well. So you can quickly see how, if I maybe put this layer on top, how you can start to quickly flesh out some really cool analysis here. Like you can check, okay, like some of these intersections, are they heavily shaded? Maybe that might affect certain aspects of either the traffic, or if we maybe look at a different use case, we can say, what about, in this certain area of Tokyo, people walking here, is it very heavily shaded? Does that impact how many people go there? Maybe the tourism sector would be interested in stuff like that. So yeah, for the next step, it would be mapping the shadow data to these roads, and then we could then directly send that to the app I showed before.
Where does this data come from? Is this something that you guys created as well?
Yes, the road data. Yeah, we manually created that stuff as well ourselves. So just to have some, if you want, especially road network data, if you want it to be 100% correct, you need to make it yourself manually. A lot of stuff out there is made with autonomous systems, so you can't really trust it 100%.
Yeah.
So that's mainly the reason behind it.
But yeah, one of the things you could do, for example, is because I know Overture has some of this. Like you could load relatively easily here, like Overture, like the entire data set. Just say, "How I want to look at it here," just for visual inspection at first.
Yeah, definitely. And you could also map this to Overture data. Like if you didn't happen to have a road network data like this, well, then you could just use Overture as well. It would still work, definitely.
This is incredibly cool. This is, I think, one of my favorite visuals that I've ever seen that you showed us. I just love how it looks.
Maybe we can try and press it a little bit. If I do 15 here, this will be.
So you're aggregating all of these runs that you've done before, or no? You're
Yes.
fetching it from the Zarr file.
Yes. So right now I'm doing 12 o'clock on the 1st of August to 12 o'clock on the 15th of August.
Right.
Just basically testing my UDF and seeing if we can actually handle it. But
how many clouds are there in Japan? Does that happen a lot, or is that just like it's really just too hot in the summer?
It's very hot. It's 35 to 40 degrees. It gets pretty bad.
Celsius for people.
Yes, Celsius. Yes. Yeah. Okay. I think it looks like it's done now. Of course, things don't change that much going from 1 week to 2 weeks. The pattern is the same. But yeah,
how do you take this? So you've done this analysis here, like you're visually taking a look at it. Like, what's the specifically for this app after, like, because I think you were telling me you guys are still building on this, you're
Yeah,
still working on it.
yeah.
What is the output that you expect in, let's say, a couple weeks or months?
Just to have a super reliable app that so it's going to be on your smartphone. I showed you a web page
Yeah,
version of it, but ideally it will be something people download when they come to Japan, and then they could use it as a super easy way of kind of like a very customized Google Maps that can help them navigate through
yeah,
this very very large city, navigate them through different POIs that they're interested in, like temples or small shrines or like small coffee shops or cafes, and give people the most pleasant way of getting from A to B. Because like again, don't take my word for it. If you wanna really experience the heat, then come in the summer. I wouldn't recommend it, but yeah, if you don't believe me, yeah. So I think it's a super interesting app, and I wanted to kind of use what I can do to help improve it,
yeah,
and that's why I've been looking at this use case. But there are many other things you can do. I don't have an example prepared right now, but from this DSM, you can also calculate things like a canopy height model. So that's just
yeah.
the difference between the ground and the top of whatever is above it. So in this case, it could be the difference between the ground and then this tree. What that would give you is the relative height between that object and that area. And once you have that, then you can start extracting trees and forests and stuff like that, which is also a super interesting use case for urban planning, for mapping out vegetation all across Tokyo. um, yeah.
Did you yeah, because this is all like point cloud, so you could really
Yes,
do like whatever. Yeah.
this is just one very specific use case. There are so many other use cases that I want
Yeah.
to explore.
If anybody has any questions as well, feel free to drop them in the chat. We'd be more than happy to answer those about what you're showing, Chris, here, some of the use cases, or how Fused works. I want to ask you here, like, what, because you've been one of the people, I think, maybe if not the person that's been using Fused the
One of
longest.
the, the, the early adopters.
We did a webinar already last year. You showed already some of the use cases, so
Yeah.
you've got a lot under your belt of using Fused. What is the value that you see in it? Like, we've gone through a couple of use cases here. You've got work to get done, right? Like, why Fused? What is the value that you're seeing it compared to, you could do this in a notebook somewhere, or in a Jupyter environment. Um, as a data scientist, like, why is this helpful for you?
So I think the biggest thing in the beginning was just two very specific things. So the fact that it's in Python, first of all, because I graduated towards Python pretty early on when I was doing a lot of machine learning stuff. And I really liked the data science part of what I was doing. So I was always working in Python, training models, and even looking at statistics and stuff when I was in university. So having it being Python, first of all, was a big plus. And then the fact that whatever I write, whatever code I write, immediately gets shown to me on the right. It sounds like a super basic thing, but people will be surprised that that's actually not a lot of app or like of tools that can do that. It's a lot of manual work. You need to first do your analysis, then you need to export that file, and then you need to upload it somewhere else where you can actually visualize it. I know there are tools like QGIS, but like I never really got around to learning that, especially not now that I have Fused. So it it just seemed like a super easy way for me to do the GIS work that I want to do, um, without having to learn a lot of new tools.
We touched on AI a little bit. Like, that's all the rage at the moment. We've added AI support in a bunch of places. So here, there's the little text box at the bottom left. You have it directly in the editor as well, where you can make a change. Have you been using this? And if you have, or if you haven't, like, I'd love to hear what your experience has been. It wasn't out when you were working on the GRIB Japanese data. We mentioned that earlier. But yeah, have you been using it? What's your process for using it or not? Have you experimented? I'd just love to know your experience.
So in the beginning, I've always been a little bit wary of AI, mostly because like I've had bad experiences with it, leading me the wrong way, or I end up wasting more time because it tells me the wrong thing, but it sounds like it's correct. Um, so in the beginning, I was kind of apprehensive, but the more I used it, and the more I started to rely on it and find like the correct way of using it as well, and when to believe myself and when to believe the AI, I started using more AI in general, and with that also comes the Fused AI. And recently, specifically, I actually think it's been doing a pretty good job. Even if it gets it wrong the first time, I believe there's a button to like fix it or something, and then it just goes
Yeah,
in and
yeah,
fixes
yeah, yeah.
itself. You press that a few times, and then more often than not, it actually gives you what you were looking for.
Do you have
So,
a use case recently where you used it and it was helpful?
so generating HTML maps is one thing. There's Fuse has something called Canvas, which people might be familiar with, which is this new dashboard functionality where people can show, or where you can basically have tables and maps and different UDFs interact with each other. And to visualize maps there, it uses HTML, which I'm not very well versed in that, so I rely on the AI to generate those maps for me, which has been super helpful. But also just small things like commenting my code or reformatting my code, making it sure that all the projections are aligned and that I'm not messing that up anywhere, especially when I project from one to the other and then back to the first one.
Yeah.
Um, and also finally explaining other UDFs, community UDFs that are there, use cases that I want to use myself, but I might not be able to understand what.
Can I ask you to show like the catalog? Like
Sure.
that's a big part as well. We are going to be sharing more about the Canvas part next week. We have another webinar that's going to be dedicated on some of that. I'll share a bit more about this later on. Um,
So yeah, this is I think the one I showed earlier today. That one
yep.
is available as well for people to check out. This one as well as this one. Make sure to use them together because this one won't work without this one. But yeah, these ones are available for people. Um, there are a few other ones that I've also pushed to community. I don't know if you've got time to talk about this today, but
Yeah.
um,
But yeah,
yeah,
this is like a catalog of all the code base as well. So when you're building something in Fused, you can choose to say, hey, I want to push this. You can connect it to GitHub. You can share it amongst your team so it stays private as well. But here, this is the community one where people have put out, I mean, just from the names here, there's zonal statistics, segmentation, looking at Landsat. Like all of these are codes that are already up there that you can use. And so you were saying, yeah, that it's been
yeah,
helpful to just understand what's going on
exactly.
in there.
So just add that to your workbench, and then if there's 300 lines of code, I just ask AI, comment this code better, or tell me exactly what this part of the code means,
Right.
explains
Yeah,
to
yeah, yeah,
me
yeah.
how this works, and how can I apply it to my own use case. Um,
Yeah, we put a video out a little while ago where I was showing that I've used it to learn about just doing SQL queries in DuckDB
yeah,
because it's something that I never spent a lot of time learning how to do. And you hear about DuckDB being this really cool thing, and I was like, let me just ask AI like to take a pandas query and then turn it into DuckDB query or SQL query, and I found that to be really helpful in not just doing it but asking follow-up questions about like, okay, why, how does it work like this, or why is this syntax there? Explain it to me. If you wrote it in pandas,
mm,
what would that look like?
yeah,
I've gotten a lot out of that. I think yeah, we could show. We've got. We can nerd out a little bit more. I think one of the cool ones is the dust data set. I don't know if that's the next one you wanted to show.
sure. This is okay. This will be the final one. We're already running over time, but let's show this one right at the end. So this is more of an experiment for me to learn more about the Zarr data format that I've been using a lot lately. So this is actually available directly infused through Source Co-op. It's someone else was kind enough to turn this global dust data. I believe it's from the Finnish Meteorological Institute. they published this global dust data about dust movements, and it's a massive data set. It's tens of terabytes in size. So, and it's a SAR file in source code. So with Fused, we can directly read this file. You can see I directly read it here remotely. And then, as has been the theme throughout today, I make it a tiled UDF. I make sure that this is basically exactly the same thing as I was doing with the shadow map, right? Only pick out the data from the SAR file that intersects with this tile. And then, yeah, we can show this super cool data. And because it's actually predicted data, we can show the time series. So these are, I believe, 1 hour increments. So as I run this, let's see, we can see how the dust basically moves. I don't know why it's not updating. Maybe not.
Do you have some cache? No, it doesn't seem like it.
Not sure. Maybe we try a different one. I do have a few that I've been working on.
I also shared it in the chat for anybody that's following and that wants to say, hey, I want to try this out myself. You can go ahead. This UDF is also public. So you can
there we
go ahead, make a free account on Fused if you don't have one already. Make a copy of this UDF and basically do the same thing that Chris is doing right now.
So here I'm just manually updating the time steps in front of you so you can see that it's moving. You could generate a GIF or a GIF from this so that you have an animation running, but this is kind of the gist of it. It's very, very large data being read very efficiently from an efficient file format. And SAR just works very well with Fused, I think, in the way that you've got this cloud native data format that can be read remotely. You've got files that are tens of terabytes in size. It needs to be stored remotely, right, in a cloud environment. So you can't have it locally. So you need to be able to read it remotely. And then the fact that you've got these tiles in UDF, where these tiles in Fused, where you can only grab that data that you actually need for that very specific place and time, is I think it's a super good match. So actually, we have a more in-depth article on our website about this specific UDF, and as Max mentioned, it's openly available to people as well if they want to use this themselves, or they want to check out the code, or take it up themselves. So yeah, check that out if you want.
Very cool. Thank you, Chris. Is there any other ones you wanted? I think there's a couple ones we haven't gone over here, but again, I'm going to open it up for questions. If anybody
I have a lot more.
has,
So people can reach out to me on LinkedIn if they want me to to show off even more stuff or go into more detail about the stuff I've shown today. So feel free to reach out if there's anything you would like to know more about.
Yeah, we're both there. You can go out to try out Fused as well. And a lot of what we've seen here, sorry, is linked in one of the blog posts that I mentioned. We'll have this recording that also goes up there. And I'm going to show this very quickly. So I'm going to bring up my screen. So here, if you go to some of the links that I've mentioned, you will see the code that Chris was talking about right here. You can then add it to UDF Builder, and you'll be able to work with it. So here, I've just made a copy of it. Well, I've just brought it in, and you can start working with this directly. So you can just head over to fuse.io/workbench. I'll also drop a link to that, and you'll be able to just try it out yourself. I want to mention a couple of things that we have, a couple of events that are coming up. So next week on October 30th, we'll have another Fuse webinar. We're going to showcase some of the canvas that Chris was hinting at. On November 3rd, we'll be at Phosphor-G North America, around the DC area. If you're there, come say hi. We'll have a talk. And then if you're in New York in on the 14th, November 14th, we'll have a PyData night where we'll be hands-on showing how to get started with Fused as well. So if you're in if you're in New York area and you want to try out Fused, you want to do it in person, we'll have some food and we'll all hang out. So please do that. We'll have a blog post with everything. And yeah, any last words you want to put out, Chris?
No, just thank you everyone for joining. I'm happy that people are here and showing interest in what I do, and I'm glad that I could share with everyone. Yeah, thank you.
Awesome. So I'm just going to drop out here a link directly to go try out Fused. I've tagged you, Chris, on a bunch of places here. So if people want to, they can just directly reach out to you. And yeah, thank you for joining, Chris. Thanks again for the time. Thanks for showing a lot of the cool use cases that you've been doing with Fused. And I'm sure we'll have some more coming up.
Yeah, thank you.
All right.